Hello everyone, I hope you all are well. As you can see, the topic name from the video itself suggests that it is state of matter. So today we will be studying about state of matter. So now, what is state of matter? First of all, we should know what is matter. Matter is anything. Matter can be anything. Everything is made up of matter. You take a brick or a bottle or a pen or a chair or a TV or shoes, anything. Everything is made up of matter. Now, these matters are of three types: solids, liquids, and gases. They are in three states. Basically, all the matters are in three states. There are solid, there's liquid, and there are gases. And all around us, we can always see many things, and everything that we see around us is made up of matter. Now, we are surrounded by a number of things. Some of them are solid, liquid, and some are in the gaseous form. As you can see in the picture here, you can see a mountain, you can see trees, you can see stones, you can see grass, you can see water, and there are many things you can see in this picture, and everything is made up of matter here. And all of these things, they are in different state. Like if you look at the stone, it is in the solid state. If you look at the water, it is in the liquid state. So furthermore, as we go into the chapter, we will be seeing more about different kind of solids, different kinds of liquids, and different kind of gases, and how different kind of matter is in different form. Example of matter. So you can see in the picture the solids, you can see hat, pencil, skateboard, and in liquid you can see soup, rain, juice, water, drink, milk, and in gases you can see the wind, the air inside a ball, from the air we get from the fan, fog. These all are examples of different types of matter. In this chapter, basically we'll be seeing these 5 topics: particle arrangement in matter, change of state, solutions, changes around us, and expansion and contraction. These are the 5 topics we'll be covering in this chapter. Particle arrangement in matter. Any substance that has mass and occupies space is called matter. All matter is made up of small particles. The manner in which these particles are arranged within matter results in the 3 different states of matter known as solid, liquid, and gas. So, every substance that has mass means it has some weight. When you put it on the weighing machine, it will show some weight. So everything has mass, and thus it occupies space. Like if you take TV and if you put it on the weighing machine, the TV might weight up to 20 kg, 15 kg, maybe. Furthermore, if it's a big television, then it's a 30 kg, and it has mass. That's why it weighs something. And when you place the TV in your house, it occupies some space of the house. So anything. So what do you understand? That TV is also a matter. So every matter occupies space as well as has mass, and every matter is made up of small particles, and these small particles, they combine together and they form the entire thing. Now, based on the particle arrangement, how these particles are arranged, the matter is formed. That is how the matter formed. Now as you can see in the picture, you can see solid, liquid, and gas. As you can see in the solid, the particles are arranged very closely. That's why they are hard and solid. When you look at liquid, the particles are not so tightly packed, they are quite lightly packed. And if you look at gas, the particles are very far apart from each other. So these are the 3 different types of particle arrangement in matter. Now, change of state. Matter can change its form from one state to another form. For example, Water liquid when heated can become water vapor, gas and ice. Solid can melt and become water liquid again. So change of state. Now we basically saw what is solid, liquid and gas. Now these are the three states of matter. And also these three states can change. For some things the state of that matter can change. For example, you take ice, as you can see in the picture. Once you put some heat into the ice, or if you leave the ice in a bowl, after some time you see the ice becomes water. So the ice which is in solid state, it is changing from solid state to liquid state, becoming water. And then if you take this bowl of water and heat it on the oven, this water will evaporate and go into the atmosphere. Now this water is changing into gas. So there are few matters which change from solid to liquid, some changes from liquid to solid, and there are some who change from solid to gas, and then they in turn change from liquid to gas. Like that there are many types of matter. So water when heated, ice when heated, it cools into water, and once this water again heated turns into air. Solid. In solid, the particles are tightly packed, so cannot move away from each other. This is why solid generally have a fixed shape. Now if you look at a stone, as you can see in the picture also, or you can take a stone from your surrounding, if you put it on the table even for an entire year, and after a year is over, you will see the state of the design or the shape of the stone has not changed. It is because it is made up of solid. In solids the particles are tightly packed, and because of this, because they're tightly packed, the particles cannot move away from each other because it is very tight. They are very tight because the intermolecular force is more high here. That is why they're tightly packed and they did not change shape. Liquid, as you can see, there's a glass, there's a glass tumbler, and water is poured on into it. Now as water is being poured into it, you can see that the shape of the water changes. You can try this at your home also. Just take a tumbler, put water in it, just pour water in it. Take a glass tumbler because it'll be easier to notice. As you pour water into it, you notice that the water, there is movement in the water. Yes. Why is there movement? Because the particles are not tightly packed. As you can see, in liquid the particles are not as tightly packed in solid. So particles are not tightly packed, so they can move and slide over each other. This makes liquid flow and take shape of the container they are poured into. So that is why, because the particles are not tightly packed, so when you pour the water, it changes shape, it slides. So these particles slide over each other and they take the shape of the container they are poured into. Like you pour water in a bottle, it takes the shape of the bottle. If you pour water into a pan, it takes the shape of the pan. Okay, so likewise liquid takes the shape of the vessel they are poured into. Now gas. In gases, the particles are far apart from each other and can move freely, so gas can flow easily and take up all the available space. So what is gas? If you take a football, have you ever wondered why it is so tight, or why it suddenly becomes less? It's totally inflated, then the inflation, slowly the air comes out. So what happens here is that you put air inside a ball. If the air reduces, the ball tends to become more you can say more like spongy type. So that's what gas. And whatever we see around us, the air we breathe and everything, this is the gas. we are having. If you take a gas cylinder, the inside the cylinder there is liquid, but once the liquid comes out it becomes gas. So these are the solid, liquid and gas. I hope you all have understood so far. Now let's look into how these state, three types of state their changes their states. Okay, see, evaporation. When water gets heated, it changes into water vapor, which is its gaseous form. Changing of a liquid into gas form is called evaporation. On heating, the particles of water start moving and vibrating faster. Finally, they break free from their existing arrangement and escape into the air as gas, where the particles can move much more freely. So now what is evaporation? Uh, Evaporation is when the top layer of the water he becomes gas due to the heat surrounding the water. It is not a heat, it's not artificial heat, it is the natural heat which is there present. So the top layer of the water evaporates and goes into the air. So water is changing into gas. Water is in the liquid form and it becomes into air, which is in the gaseous form. That is basically called evaporation. Now condensation. Yeah, you can try this experiment at your home also. Take a glass of water, take a glass and take a glass and put some ice cubes into it and leave it outside for some time. After a while you will notice there are you'll see there are water droplets sticking to the glass. So around the glass all the water droplets are there. You might not have known why, but the reason is condensation. What is condensation? Basically, the air around the glass or the tumbler is becoming cold. Is cooling. So when it cools down, air becomes into water. So see, when the freely flowing particles of water vapor touches a cold surface, so these water vapors which are in the air, when they touch a cold surface, they cool down and become water. So change of a gas into a liquid is called condensation. Water vapor condenses to form water. Cooling substance slow down the movement of its particle, therefore the particle become less free to move, thus forming a liquid. So now these particles in the air, as I told earlier, that they are moving freely, but once when they cool, they cannot move freely and they become, that is the reason they come closer to each other and they become liquid. Now if you want to try example condensation, you can just take a pan, boil water into it and boil the water. Once you see the vapor coming from the water, just put another plate on top a little further higher than the pan and you'll see there are water droplets on the plate. This is the reason. The reason is the water vapor is getting cooled near the plate and is becoming into water again. Melting. Two particles in an ice cube rigidly the particles in an ice cube rigidly packed to give fixed shape. So it's not two, it is particles in ice cube. The particles in ice cube are tightly packed. Now if you take ice cube, the water particles are very tightly packed and that's why they form a fixed shape. When an ice cube is taken out of the refrigerator, it melts gradually. Changing of a solid into liquid is called melting. This is because in a warm place, the particles in ice starts vibrating faster and finally breaks away from the rigid patterns. They become loosely packed as in liquid and form water. Now, when you put an ice cube outside the fridge, you might have noticed the ice cube will turn into water. The reason is the ice cube is observing the heat around it. and because of this heat the particles are getting energy to break, and these particles break apart and they become loose, and because of this, but they don't become so much loose that they can escape. They become loose and they become liquid. Solidification. Solid means it's hard. So basic solidification is changing of liquid or liquid or gas into solid. Changing of a liquid into solid form is called solidification. We all know that water form ice upon freezing. Freezing is a type of solidification. Other substances also change state and the particles behave in the same way as that of water. The particles move faster when heated and slow down when cold. So in solid, if you take again thick water and put it in a container and put it in the fridge, after a while you will notice the water has been turned into ice. This is the reason behind is these particles which are slightly freely moving in the water, when they are cooled they get cooled in the freezer, and because of this they get closer to each other, they cannot move, and then they form hard, they become hard, and that hard thing is called ice. So basically on heating the particles become loosely packed, and when cooled the particles are they tighten themselves. Solutions. Water solution, basically every day you see a different type of solution that's made in a house. You might have put some glucose into a glass of water, or you might be taking lemon juice or many things like that. So or you can take tea. So these are all basic solutions. What is solution? Basically when something is mixed into water or into a liquid, when there is a solvent and a solute. We'll look into it. When two substances are mixed together, they're mixed together such that they're evenly distributed. Once they're mixed, it's not like that one thing is taking one part and the other thing is taking other part. No, they are completely mixed together and they're evenly distributed. Then a solution is formed. The substance that dissolves is called the solute, and the substance which it dissolves is called solvent. So there are two substances. One substance is mixing in the other. Now if you take sugar and put it in a glass of water, so sugar is mixing in the water, not water is not mixing in the sugar. Sugar is mixing in the water. So sugar is the solute and water is the solvent. For example, when salt is added to water, it dissolves to form salt water. Here salt water is the solution, salt is the solute, and water is the solvent. So it is not what, it is water is the solvent. Okay, so I hope you understood. You take salt, mix it in water, salt is the solute, water is the solvent. When you mix them together, it becomes a solution. Most substances dissolve in water, hence water is known as the universal solvent. So if you take water, it kind of dissolves everything. Not everything, sorry, most of the things. So that is why water is called universal solvent. Solutions may be of different types depending upon the state of the solute and solvent present in the solution. Now solution also is of different type. It depends on what two substances are being mixed. Are you mixing a solid with a liquid, or are you mixing liquid with liquid, or are you mixing liquid solid? So there are different types, so we'll be looking into that also. Solid dissolves in liquid. Solid means a hard stuff, liquid means a free flowing thing. So the example I gave earlier was salt and water, sugar and water. Here you can see again salt and water. You can take for example bleach. You can take any hard substance mixing in solves into a liquid solid. You take a glucose, or you take your uh, all the health drinks you get, like a Bonvita, Horlicks, those are all kind of solid. So these, when you mix it in milk or in water, they they dissolve in the milk or in the water. So here it is solid dissolves in liquid, where liquid is the solvent, the solid is the solute, together they form a solution. A liquid dissolves in liquid. Now when they're mixing a liquid into liquid, now if you take for example milk, and you want to make some, and there is only one glass of milk, but you want 2 glasses of milk. So what do? You add some water into the milk. Because you add some water into the milk, you get to see that the water dissolves in the milk. So here it is liquid dissolving in liquid. So this type of solution is formed when solute and solvent are both liquid. So this is when both the solute and the solvent both are liquid. Okay, for example, you can see milk in water, which is basically milkshake. Okay, now solutions. Now gas dissolves in liquid. Now how, when you are mixing gas in liquid, this type of solution is formed when the solute is gas and the solvent is liquid. So this is when do you get this one? Solute is gas and solvent is a liquid. Okay, now you all might have in some place or somewhere, you might have bought a Pepsi bottle or a Coca-Cola or a Limca or Sprite, Mountain Dew. There are many types of uh, carbonated drinks which you buy often, and you might have noticed when you just open the cap, you might have heard the hissing noise which comes out. That's basically gas. So this gas is mixed with the liquid. So once you open the cap, this gas comes out. So here what's happening is gas is mixed with liquid. So the extra gas which is there in the bottle comes out. Gas dissolved in gas. Now here, when gas is mixed with another gas, this type of solutions form when the solute and solvent are both gas. Example, air, which is a mixture of different gases. Now in this, when gas is mixed with gas, this is another solution. So the most common example is the air around us. In the air there are many types of gas like nitrogen, hydrogen, oxygen, and many other gases which are in the atmosphere. Now let's look at, now as we studied about solutions, there might be situations where the solute and the solvent might not mix. Like we took sugar and put it in the water and it got mixed. But if I take a stone and if I put it in the water, it will not mix. If I take some sand and put it in the water and stir the water, you'll notice a brown color water, but after a little while, if you leave the glass of water, you'll notice the water is clean again and all the dirt is settled on the bottom of the glass. So in this case, you see that the stone is not dissolving in the water, the sand is not dissolving in water. So there are instances when they do not mix. So these type of, so there are these cases. But now we'll be seeing about when liquids, when we are mixing two liquids. Here the solute and the solvent both are liquids. So when we mix them, we'll see whether they're mixing, are they dissolving in each other or are they not. So based on that, there are two types, miscible and immiscible. Basically miscible means in which they are able to mix with each other, and immiscible means in which they do not mix with each other. Now if you look into this example here in the picture, okay, let's read the bottom first. When two liquids mix together such that they dissolve completely in each other, they are called miscible liquids. So see, what is miscible liquid? Is they dissolve completely. two liquids, two liquids, notice that two liquids mixing with each other completely, they have to mix completely with each other, then they form a miscible liquid, and it's a solution. So for example, when milk is mixed with water, I told you earlier, or you can take a lemon juice, which when you mix in water it mixes completely. So there are many instances when you actually get to see miscible liquids. And look at immiscible liquid. When two liquids mix together such that they do not dissolve completely in each other, they are called immiscible liquid. So in immiscible liquid, it is they do not mix. You again take two liquids and you mix them together, and you notice they do not mix. As you can see in the example here, when you pour water into oil, they do not mix. Now you can try this example at home also. Take a small glass, pour some water in it, and pour some oil also into it, and you will notice the oil floats above the water. The reason is because oil is lighter than water, so oil floats above the water and they do not mix. So this is a case of immiscible liquids. Now we'll see physical and chemical changes, all the changes around us. Changes occur all around us. Cooking of food, drying of clothes, growing of trees, and ripening of fruits are examples of different changes that occur around us. All changes can either be physical or chemical, depending upon whether a new substance is formed or not. Now, every day we see different changes. Every day. Like you wake up in the morning, some days it is very bright, there is sunlight, and some days you see it is very cloudy. Then as you go to the kitchen, your mom has prepared some food. You see that when mom boils the egg, which is in a liquid state, once she cooks it, it turns into something else. It becomes an omelette. And likewise, you take a pumpkin, which is a very hard substance. Once you cook it, it becomes an entirely different substance. It becomes very soft with lot of flavor. So these are all changes. So basically there are two changes, chemical and physical. So what do you mean by physical and chemical? We'll look into further into physical changes. Physical change is the type of change in which only the physical state of substance changes and no new product are formed. Ice cube kept out of the freezer for some time will change into water. Change occurs only in the physical state of the substance. No new substance is found. Melting of butter, breaking of glass, melting of ice cream, tearing of paper are all examples of physical changes. So in physical change, physical means the shape, the design of something. So only that changes. Nothing new is formed. Now, if you take water, take ice cube, and keep it outside for some time, it will turn into liquid because of the heat around it. So in this, when it is ice, it is water only, but in the form of ice. Once it melts, it's still water. So here only the shape has changed. Only the shape has changed, the substance has not changed. When it was ice, it was water, and once it melted, it did not become vinegar, or it did not become orange juice, or it did not become some other thing. It was again water. So in this, no new substance, nothing new is formed. It's just water into ice. Some examples are melting of butter, breaking of glass. When you break a glass, you're just breaking the glass. Nothing new is formed. The glass does not turn into stone. So these are all physical change. I can see in the picture, the ice is turning into water. A change in size, shape or state, but not in identity, means the actual thing, what is it? It does not change. Now here are other pictures. You can see a breaking of glass, broken pencil, paper which you tear it, and you see ice cream also melts, but even after melting it's still and ice cream, though in the liquid form. Now let's see chemical changes. Chemical changes Chemical changes is a type of change in which the chemical composition of substance changes and a new substance is formed. Burning of paper is an example of chemical change. In this change, the original substance paper changed into a new substance ash. Rusting of iron, making curd from milk, and cooking food are all chemical change. So in chemical change, something new is formed. If you take uh, egg and cook it, it becomes into an omelette. So something new is formed, completely new. If you take some rice, raw rice, put it in the water and boil it, it becomes cooked rice. So which was hard, it becomes soft. So here something new is formed. So whenever something new is formed, it is basically chemical changes. Rusting of iron is another example. There are a few examples. Making of curd and cooking of food. These are all chemical changes. You can see here burning of wood. When you burn wood, it becomes ash, a black color substance. So here wood is changing from wood to ash. Something new is formed. So this is a chemical change. Cooking of egg, iron also. When iron is get exposed to air, it becomes rust. These are all changes. Now we see expansion. What is expansion? When something expands, if you take a rubber band and pull it, you can see it stretches. So basically, the particles in the rubber band are expanding. That is why you can stretch the rubber band as much as you want. Not as much as you want, as much as it is possible. When the substance is heated, the particles start vibrating rapidly. Thus, each particle takes up more space due to its increased movement. So, substance expands. Now, if you take ice, give it some heat, what happens is, because of this heat, the particles in the ice start vibrating. Because they're vibrating more, they gain energy. And because of the heat energy they get, they are able to move away from each other and they become liquid. So here the particles are expanding. Okay, so thus the increase in the size of matter on heating is called expansion. Basically, the increase in size, when something's size increases by heating, that is called expansion. Heating a substance can make it expand. This explains why a tight metal lid of a glass jar can be opened when dipped in warm water. The water hits the lid, causing it to expand a little and open up easily. Now there might be some case where the can it has a metal cover and cap and it's hard to open. So just put it in warm water. After a while, the cap opens nicely. The reason is because the metal cap expands in water. Not in normal water, it expands in warm water. And thus, because of the heat, the particles are expanding and they become loose, and that is why you're able to open it easily. Contraction. As you saw, expansion. Contraction means when the particles which are moving freely, again they become close to each other and they cannot move freely. This happens when they are cooled. When you give cold, or when something is cooled, they become cool and they turn into a hard substance, and basically the free moving particles are taking the coldness and becoming hard, and they are becoming close to each other. Because of this, they are losing the energy. Basically, when they cool, they lose their energy, and when they lose their energy, they cannot vibrate more, and because they cannot vibrate more, they are staying in one particular place and they form into a solid. So the decrease in size of matter on cooling is called contraction. So far this is what the chapter had. I hope you all have understood. If you have any doubt, you all can ask me in WhatsApp. Thank you, students.